Okay, here is your test 3 review video. For number 1, we are multiplying two fractions. We're going to factor wherever we can, and then we're going to multiply across the top and across the bottom. So my factoring methods for here are difference of squares. Here is the short cross method when a equals 1. In this first numerator, I can't factor, so I'm just going to leave it as 2 times x. Remember, multiplying fractions, you go across the top, across the bottom. So the second numerator, difference of squares, is going to give me x minus 3 times x plus 3. And in this first denominator, my cross method, what multiplies to AC and adds to B. A is 1, so A times C is 12, B is negative 7, and the two numbers that work there are negative 4 and negative 3. Since this is our short method, we can go straight to factored form. And then for 6x squared, we don't need a factoring method, we just need our regular factoring. 6 is 2 times 3, and x squared is x times x. So we cancel things that are the same on top and bottom in pairs. So I can cancel the 2's. Remember, every time you cancel something, it leaves behind a 1. 1x and x minus 3. And that's it. So what I'm left over with in the numerator is x plus 3. And on the bottom, I'm left with 3x times x minus 4. In the second problem, this is an add or subtract, which means we have to make common denominators first. So we start with the 6 and the 9, take the biggest one, and write multiples of it until you find one that the 6 goes into also. So if I start with 9, 18, 27, I can see that 18 will work. And that's just for the number chunk. For the variable chunk, you use the variable with the bigger exponent. So here's my least common multiple, 18x cubed. And I need to multiply each fraction by whatever I need to make their denominator match this common multiple. So in the first fraction, I need to multiply the 6 by a 3. And whatever you do to the bottom, you have to do to the top. I don't need to change x cubed because it already is x cubed. And then for the second denominator, 9 times 2 will give me the 18 that I need, and I need 2 on the top and bottom. And then I need one more x on the bottom, so I'm going to multiply by x top, numerator and denominator. So now you do the multiplying on your fractions before you worry about the subtraction. So multiplying means going across the top and bottom. So that's going to give me 21 over 18x cubed minus 4x over 18x cubed. And now we can do the subtraction, which really just means combining them into one fraction. This next problem is dividing by a fraction, so that is going to be where we do keep the first fraction the same, change division to multiplication, and then flip or take the reciprocal of the second fraction. So real quickly before I do that, I'm going to make a plan for what factoring methods I need. And both of these situations are the short cross method. So one shortcut we talked about in class is just go ahead and make your one big fat fraction bar and combine all these steps together to save yourself some time in writing. So I'm going to worry about this first fraction before changing and taking a reciprocal. So this first numerator what multiplies to 35 and adds to 12, and that's 5 and 7. So that factored is x plus 5 times x plus 7, and I have an x plus 5 on the bottom. And then changing to multiplication and flipping the second fraction. So this denominator is now going to be in this numerator. And I'm multiplying by just going ahead and writing everything together in one fraction. I've just smushed it all together, and I've already multiplied. And then factoring the x squared plus 10x plus 21, what multiplies to 21 and adds to 10, and that is 3 and 7. So x plus 3 times x plus 7. Now let's see what cancels. We have x plus 5, x plus 7, and x plus 3. It doesn't always happen that everything cancels, but this time it does. And remember, what happens when stuff cancels is it's really something divided by itself, which means 1. So each of these cancellations leaves a 1 behind, and they're all being multiplied together. So 1 times 1 times 1 is 1. Number 4 down here is another common denominator problem. Start with your biggest number chunk and find multiples until you get to one that works for the other number chunk. And even though I listed 3 multiples, really I only needed that first one, the 10. They both go into 10. And then whichever variable has the biggest exponent, the x squared, that's the variable part of your common denominator. So now I rewrite them. In the first numerator, I need to do 5 times 2 to make it have a 10. And it already has an x squared, so I don't have to change it anymore. For this denominator, it already has a 10, but it needs one more x. And what happens here, because the numerators are binomials, now I have a distributive property situation here and a distributive property situation there. So I'm going to go ahead and combine everything in one big fat fraction with a common denominator of 10x squared. This first distributive is 6x plus 4, and then plus, that comes from here. The second distributive is a 7x squared minus 4x. So now I'm going to combine like terms and write in standard form. So 7x squared comes first, and then 6x negative 4x is a positive 2x, and then I have plus 4 here, and then I have my common denominator on the bottom. Okay. This next problem is one division fraction. We're going to factor the top and bottom and see what cancels. My numerator here is the long cross method because a does not equal 1, and the denominator is difference of squares. So I'm going to start with the numerator. What multiplies to AC and adds to B, so that's negative 15 and negative 2. And what will work there for me is negative 5 and positive 3. So on the long method, we are using those two numbers to split and rewrite the middle term, the negative 2m. My first term is going to stay the same, 3m squared. My middle term now becomes 2, negative 5m and 3m. And then the last term is 5, negative 5. I do my grouping. I GCF the first group, so m times 3m minus 5. The second group, they do not have, they're all prime, so we're going to use 1 as their GCF. That's the only thing they have in common. And now between the two groups, they have 3m minus 5 in common with an m plus 1. So that is my factored numerator. And then difference of squares on the bottom gives me m minus 1, m plus 1. So the common factor here is m plus 1. leaving me 3m minus 5 over m minus 1 as my final answer. And then on the back, both of these problems on the top already have a common denominator. So we are going to go ahead and combine. So common denominator already matches. Now just combine the numerators, n squared plus 6n. GCF both of these. So that gives me n times m plus 6 over 5 times n plus 6. Cancel, cancel. And I have n over 5. Again, on 7, they already have the same denominator. So we go ahead and combine. Now we factor long cross on top, short cross on bottom. So then the numerator I have 2t squared plus 8t minus 3t minus 12. We do our grouping. That's going to give me t plus 4 times 2t plus 3. And in the denominator, I have t plus 4, t plus 4. Cancel, cancel. And this is my final answer right here. And then number 8 is another division by a fraction. This is a complex fraction. We're going to keep this the same, change to multiplication, and flip the second fraction. And I'm going to factor as I go. So this right here is going to be short cross. And this one right here is difference of squares. So first one, 9x squared becomes 3 times 3 times x times x. And its denominator, what multiplies to 30 and adds to 11, that's 5 and 6. So I have x plus 5 times x plus 6. Now this bottom one, I'm going to flip and factor at the same time. So the 3x squared is on top. It's now going to go on bottom, 3 times x times x. And x squared minus 36 is now going to go on top, and it's x minus 6, x plus 6 for difference of squares. So gone, gone, 2x is gone, 1, 3, and that leaves me 3 times x minus 6 over x plus 5. And then the last one, change this to x squared minus 36. And this is an area problem, length times width. So it's really just a multiplication problem. And I may not get to finish this before the recorder cuts me off, but we'll try. You can always look at the answer key PDF in your Google Classroom if I don't finish. So this is almost everywhere just a GCF. This GCF is 2 times 2x plus 3. This other denominator is a 5x squared times x minus 6. The second numerator is a 5x squared times 2x plus 3. And then this numerator is difference of squares. X minus 6 times x plus 6. Cancel. X minus 6 is 2x plus 3, and 5x squared leaves me x plus 6 over 2. And I finished before the 15-minute mark. So enjoy.